last year, you just walked up to the school.
Okay, so today we are doing volumes of washers, which is very similar to the disc method that we did yesterday, except we're going to have two radiuses or radii that we're going to be looking at, and we're going to subtract the smaller one from the larger one. So the way that we set up these integrals is two ways. I'm going to show you both ways in the notes. So the first way, assuming that r is the inner radius or the smaller one, little r, sorry, and big R is the outer radius or the bigger one, we would do volume is equal to pi times the integral from a to b of the big R radius squared minus the smaller r radius squared dx. Or you can set it up in two different integrals, subtracting the second one from the first one. So it could be volume equals pi times the integral from a to b of the big R radius squared minus that same integral with little r radius squared. Either one of these will work if you plug it into your calculator. So it's kind of up to you how you choose to do it. And then we're just going to go ahead and jump right into an example.
How many examples are there today?
I have 7 in total, but that doesn't mean we'll do all 7. We're definitely doing more than 3. 2.
I have a major headache. I feel dizzy. Pass out, so we can all go. Traumatic experience. You know, if somebody dies during
Your final exam, everyone passes.
thank God.
See, I don't think that's actually a thing.
It is actually in
And
college.
if the building you like go to school for like burns down, everyone automatically passes that class.
Yeah, I don't think that's a thing either.
It's in college rules. I looked it up multiple times. I'm willing to go to jail for arson for other people.
I'm gonna die.
I'll take one for the team. I guess. And then there's something else, like if something happens, everybody gets their degree.
What the?
I don't think that.
Everyone graduates.
I don't think that. I don't think that. Because you have, like,
Okay, so just like yesterday, we're gonna have one situation that we're going to use several times with different rotations. So this is the information that we are going to use for, I believe it's at least all 7 examples. So this says to find the volume of the solid formed by revolving the region bounded by the graphs of y equals the square root of x and y equals x squared about b, and then our rotational line is changing each time. So for the first example, we are going to rotate about the x-axis. So I'm going to first draw a picture of what this looks like. Okay, so this is just basically graphing these two functions and then seeing where they intersect and what it looks like in comparison to my axes.
Is a picture necessary?
Yes, you definitely want the picture to identify a top function versus a bottom function. And also it's helpful when we start to look at rotations. So when I graph this, I have the two functions. The first one is y equals the square root of x. And the second one is y equals x squared. So together they form that shape, and that shape is what is being rotated here. In order to come up with some bounds, I have to know where those two functions intersect, since none of that information was given to me in the summary up top. So how do you think I'm going to find where they intersect? Set them equal to each other, solve for x, and then plug x back in to figure out what our y value is. Yes. And actually, I'm just going to tell you that they intersect at 1, 1. But you know how to do it on your own. I'm not worried about that.
Wait, what are
So
we
we set
supposed
this
to do?
equal to each other.
So we set them equal to each other, solve for x, and then plug x back into each function to ensure that it gives you the same y value, and it does. So that's how you would find their intersection. We have to know both the x and the y for that intersection, because sometimes I'm integrating on the y-axis domain, and sometimes I'm integrating on the x-axis domain. So it's helpful to have both. Are we all okay so far?
How would you even solve it if there was any?
It's in the notes, but
I'll look at it.
yeah, look in the notes. It's not hard. Okay, everyone okay so far? So what I have to know next is I have to know what I'm rotating around. What am I rotating around?
X-axis.
X-axis, which means it's a horizontal rotation. And it means that my integral will be in terms of x, which is awesome for me because it means I don't have to do any conversions. If we're rotating vertically, remember we have to change everything in terms of y. So that is very important here. So since I'm rotating around the x-axis, which is this red line right here, my radii are going to be as follows. My big R is going to come from that top function. My little r is going to come from that bottom function. Because when I rotate this, I only care about this shape being rotated. I'm going to have excess space that I'm going to have to subtract out. Does that make sense, how we found our little and big R? Does it make sense why we have to have them? Because when I rotate, there's going to be empty space that I have to accommodate for. And that's what the little r here represents, is the empty space that we're going to have. Everyone's okay so far? So then what I have to do is I have to figure out what that big R and little r are. I know that was a lot. In other words, which functions are determining that big R and that little r?
Big R is x squared.
Oh, big R is my top
it's square root
function,
of x. Yeah,
which
yeah,
is the green one, which is square root of x.
I was confused about colors.
And my little function is my bottom function, which is x squared. Everyone see how we got that? Because each of those curves, their function gives me underneath of it, or between that and the axis respective to it. So then I just have to figure out, okay, what am I going to do with that r? Well, when I rotate, it's forming a what? A circle, which means that radius is going to have to square when I plug it into my volume integral. So this is going to be the volume from 0 to 1, because that's my x domain. Of pi times my radius is going to be big R squared minus little r squared. So square root of x squared minus x squared squared, and then dx. And then you just plug it into your calculator. You can also put the pi out front since it is a constant, but I like to keep it all in there. And we square the radius because the area of a circle is r squared. Just make sure you know that. What did we get? 3 pi over 10. Yep.
I do like that his gas is gonna be the 3 pi.
I know. You can, yeah, you can turn it into a fraction on yours.
So what is the decimal?
0.3 times pi.
0.9424.
Or sorry, 0.945 or 9425.
There you go. I will accept either the decimal or the fraction. Yeah, you can do it on your calculators too.
Oh, well, you got it wrong.
There you go. Why don't you just bring the calculator? One you got from me or yours? Okay. Do you want to borrow one from me?
All these are good.
I don't know. I have batteries. I put them in and it's all done.
I'll just use one.
You can use this one.
I don't know. What the heck is this?
It's a calculator. It's just the older version of the one you have. Okay. Do we have any questions, concerns, or issues so far?
I'm still working on it. I got the
Did it with the
You don't need that.
fraction.
No, I've got all my work done.
It's under that, at the very bottom.
Yeah, you can change anything into a fraction.
I know
Whoa.
what's happening. I don't
Not
know.
fraction anymore. I put pi in.
Devin, turn around and help Aaron.
Yeah, mine's just-
You take pi out, it'll turn into a fraction, but I put pi back in.
Oh, okay. That's silly.
No, actually,
Different than mine.
I'm not actually sure why mine shows.
Oh, yeah, that's gonna be the funky integral. Take the batteries out of that and put it on one of those.
I was okay.
Actually, no, it's in mode, I lied.
Actually, yours,
It's in the bottom of mode.
Sure.
it's like, it's red, but
So,
it's
without
plastic.
Now you can take the batteries out.
I don't want
Okay, I'm gonna go ahead and set up the next problem since I think everybody except for Erin has figured it out. Rob, you okay? Okay. Anybody else still plugging into their calculator? Does this make sense?
Yes.
Is it that much different than yesterday's? No, it's just that one little extra step.
Do we have to do the weird thing where we have to subtract, like,
Numbers.
yeah?
Yeah, we're gonna do that.
What are you talking about?
Okay, so this is B. This time we are rotating around the y-axis. Again, I'm going to draw the picture
all has to go by.
of what this looks like.
Is it the same?
Axis.
The axis. That's funny. Yeah, we're using the exact same functions. We're just rotating differently for all of these. It will be the same volume that we expect it will be. It should be.
So that one, it's like, you have inverse functions. Just give you like a thing right in the middle.
Okay, are we ready?
No.
Maybe, no.
And then
Okay,
we just set it back. Once we put them in terms of y, we just set it back each other. Find the.
I'll get into the integral. I guess I'm heading to what we're asking, but let's just work through it. Okay, so what is the first thing that I notice? It's y-axis, which means I need to do what with my equations? Turn them in terms of y. So y has to be in the middle, x has to be solved for. So I'm going to start with the y equals x squared. To get x by itself, I just square root the y. And then for the y equals the square root of x, I just square both sides, and I get x equals y squared. So I'm still color coding them the same. And since this time I'm rotating around the y-axis, which is this one right here, my radius are going to change for these. Because now my radius is going to be from the graph to the y-axis. So which one is considered my larger function if I'm comparing to the y-axis?
Y squared.
The X
The x squared, which is actually square root of y. So that one is going to be my big R. What then is going to be my little r?
The Y squared.
Yeah, the y squared equals x. That is my little r, or the blue one up here. Other than that, we set it up the same. We are still integrating from 0 to 1 because on the y-axis, they intersect at y equals 1. So the integration still works out the same. It's just the functions I'm plugging in are different. So my big R, we already established, is the square root of y. My little r then is y squared, and I set up my volume. And it should come out to the same answer, yes.
So I can do pi first, right?
Yes, you can put the pi out front. Or you can put the pi in the middle, it doesn't matter. Does that make sense how we did it so far?
Oh. My head hurts.
Did we still get that same decimal for anybody who's done it so far?
Yeah.
Or that same fraction?
I did at first, but it was because I forgot to vote. Yeah, it's right now.
Okay, how are we feeling so far? It's easy, like is it making sense?
Yeah.
Okay, anybody confused? Okay, let's go ahead and do example part C. This time we are going to rotate around the line y equals -1. I'm going to do the same thing I did before. I'm going to graph my functions just so I have a picture of what it looks like. I know their intersection point. And then I'm going to draw the line about which I am rotating. Which is that green dotted line at the bottom.
Now, do we draw the washer all the way down to the line?
No. We are just rotating around that line. Which means I expect that my volume is going to change because now I'm increasing the circle that is making. Everybody okay with the picture? Okay, is this a vertical revolution or a horizontal revolution? Horizontal because it's rotating around a horizontal line, which means it can stay in terms of x. I'm good there. All I now need to figure out is what my r's are, right? So we're gonna start with the big R. Which of these two functions does my big R come beneath or
It's in that middle.
beneath? Yeah. Which one is it? Sorry. Green. This is my big R, but it's no longer stopping at the x-axis. It's going down to that rotation line of -1, which means big R is going to be equal to my function square root of x minus my rotation line of -1, which simplifies into square root of x plus 1. We always have to subtract from it the line about which we are rotating, because that tells me the distance between them. Same thing applies for my little r. Which one is my bottom function here? X squared. Same with the previous one. I'm going to take x squared and subtract from it the line about which I'm rotating. So it's going to be x squared minus a -1, which becomes x squared plus 1. And then I integrate like normal. So my volume is still going to be equal to pi times the integral from 0 to 1.
Wait, it's still 0.
No, it's not, is it?
-1 to 1.
No, x-axis is still 0 to 1, sorry.
Oh, okay.
Yeah, x-axis is still 0 to 1. Yeah, that was my bad, I'm sorry. So it's top function, which is square root of x plus 1 squared, minus bottom function, which is x squared plus 1 squared, and then dx. I just plug it all into my calculator again.
My brain.
Is it -11 pi over 30?
I got 29 over 30 pi,
Yeah.
or 29 pi over 30,
I got 3.06.
which should be, I think, about 29.
Yeah, I remember what I did wrong.
Okay.
I got
Same thing Deanna did.
Oh,
3.0369.
yeah.
Okay,
Yeah.
I thought.
That's what mine comes out to be as well.
I'm
Oh my gosh.
We're gonna do, I'm thinking 2 more, 3 more. We'll do 3, and then we're done.
I wanted to-
Yeah, I didn't even
So
get
6, 7,
29 pi over 30, I got 3.03.
Yeah, so yours just must have been a more complicated fraction, or your calculator sees it as a more complicated fraction.
I couldn't even get a fraction out of this.
That's silly. Well, I did mine like antiderivative way. That's how I got mine.
So
Because I
you got
like exact
3.3.
values. But it should be 3.0369.
Better.
Right.
It took a bit to calculate though.
Mine would be fun.
Mine's loaded.
Good, right?
How do we feel so far though? Like, okay, we don't feel overwhelmed or crazy? Okay.
Yeah.
Yeah.
I'll do this for my project.
To your project. Okay.
Actually, I don't know about the first time I was here, but.
Just be instructions.
Okay. Ready? Next one we are going to do.
How many examples did you say there were?
There's 7 in total. We're gonna do this one and one more.
We're already on 4.
Yeah, we're gonna do this one and one more.
Is that her?
Oh, so we're
doing 5. Okay, she said
Did she say 3?
No, I just changed my mind. Oh wait, hold on. We're doing 2 more after this one, so maybe it's still 3.
No.
Wait.
Okay, so first thing we're gonna do is draw this, because I always think a picture is super helpful.
That's gonna be B here, yeah.
And then I'm rotating around the line y equals 3, which we're gonna say is up here.
So it's just like the one yesterday, like 3 R.
Yeah. 3 minus r.
So now I'm kind of thinking that the y equals x squared is a bigger, or no, the y equals square root of x squared. But it's farther away. No, I lied. Is the x squared farther from the line, so that's our big R?
I think 3 is the big one.
The one farthest away from our line of rotation is the big one.
That's what I was trying to
Yes.
say.
The one farthest from our line of rotation is our big one. So here, that would be y equals x squared, correct? Because we're rotating here, and this one is clearly farther away. So that's going to be my big R on this one. So big R is going to go from my green curve all the way up to that line of rotation. Which means my little r goes from the graph or function that is closest to that line of rotation to the line of rotation. So that's going to be the blue curve right there.
And then you add.
We'll do 3 minus them, yes.
And we still go from 0 to 1.
And we're still going from 0 to 1 because it's still a horizontal rotation. Remember, these functions give me the length underneath the curve. So since the 3 is above, we do 3 minus the curve to get the radius. If the line of rotation is below, we do function minus the line to get the radius. So if it's above, we do this one first. So my big R is going to be 3 minus that x squared function,
Why is it 3 minus?
because the 3 is on top. So I have to take 3 minus the distance under the curve, because that tells me the distance between the curve and the line 3.
But what if we're like straddling the line?
What do you mean by straddling the line? Which line?
If we were doing those two functions over y equals 1/2. What do you do to find the
Well, I'd have to find the intersections, and I'd have to do 2 different integrals from there. Yeah, so it would be quite different if we were in the middle of that graph. It would be quite different. I've never seen them give one like that on the AP test. Okay, so little r then would be 3 minus square root of x. Why could I leave it as x inside of my function and not change it to y? Because it's horizontal, which stays in terms of x, correct? And now I just set up my integral to get a negative volume. You shouldn't. I got 17 over 10 pi, or 1.7 pi, or whatever you're doing.
What's the decimal for that?
1.7 pi would be 5.3407.
Okay. Yeah, mine didn't get the pi either. Did it? Fraction like that.
How are we feeling?
I'm still trying.
Still trying? Okay, I'll give you a minute.
Wait, what did you say?
5.3407.
I'm scared next thing you're going to give us one that is a vertical rotation, and I don't want to do it.
I am going to give you vertical rotation next.
I guess we already did change it.
Yeah, we've already done it once, so it's nothing crazy. I love when kids stop just outside their classroom to finish sending whatever text they were trying to send before they go back in. Like, it's just interesting.
What is the decimal?
5.3407, sorry. No, I'm wrong, it's good. Okay, so this time we are going to rotate about the line x equals -3. So again, the first thing I do is I go ahead and draw my functions. And then I draw the line about which I am rotating,
X equals negative.
-3.
My face is burning. I was so burning.
Okay.
Maybe that's why I feel so bad.
That's kind of weird.
It is definitely weird.
The green line.
What do you guys think? Which one of these is going to be my big R? So they're going to be the distance from -3 to the blue or -3 to the green?
Blue.
Blue, because it's farthest away from my line of rotation. So that's my big R. My little r then is going to be the distance from my line to my green curve. Are we all okay with that? Yes.
How do we know
Does
which
R
side of the
bounce?
sun?
No, because I'm still going from 0 to 1 on the vertical as well because it intersected at 1, 1.
So it's where it intersects.
Yes, because it didn't give us other bounds, I can only find the volume between the two curves. Yep. Okay, so what kind of rotation is this?
Circular vertical.
Vertical and circular. So that means I need to have my equations in terms of y. So we already established that x squared becomes x equals the square root of y. And we established that y equals x becomes x equals y squared. And those are what I'm going to use to set up my radii. So my big radius r is going to be what?
Y squared. Plus
Square root of y minus a -3, which becomes +3, yes.
basically, it was
Yes, I will give that one to you. You just used the wrong function. And then my little r
to be fair, I was looking at that.
is going to be y squared minus a -3, which becomes y squared plus 3, and then I integrate like normal.
And would it be like -3?
No, y is still going from 0 to 1.
What the? When do you change it?
It's in terms of y now.
And my y-axis has the same intersection value as my x-axis. So here we would change it if it wasn't 1, 1. We would change it if it had a different y for the intersection.
Yeah, you're so pretty.
She said you're so pretty. And you should get 23 over 10.
That's same as 7.2.
It's actually not exactly 23 over 10.
I know, but. 7.2257.
You were
I got -7.
I'm recording, yeah. And I'm unmuted, so it's perfect.
The thing is, did you do that wrong?
Is it negative or no?
Oh, never mind.
No,
Did you do it
I don't think I
Oh,
did.
okay.
I got the answer as negative.
You did something wrong. And we're gonna do one more, then we are finished.
This next
How
one
did you
is
get
small.
23 over 10? Did you enter it right? Like, it's not exact.
It's
Not
okay,
close
I accidentally subtracted the wrong.
I'll go back and look at my work.
Well, because I have 2.300000446.
Yeah, but I only go to 4 decimal places, so it came out close enough that it rounded to 23 over 10 when I was doing mine.
Okay.
Yeah.
Oh, okay.
I just
Last
had
one.
to,
Last one, are we ready?
yes.
This one's my favorite one.
Yeah, so it's probably the worst.
It's that.
It's giving people S. That's your favorite one. Letter S. No, I have all these if I didn't take note.
Oh wait, is this like a whole new example?
This is
Well,
a whole new example.
You pull out trick functions and one example.
There are no trick functions in this one, but good to know.
I'm walking in. I don't care. I'll pay the difference for the test. I won't take the AP test. I'll walk right now. It's like 30 bucks. I don't care. I have that.
It's $30 to buy, not take it.
It's a paper test. If you don't take the AP test, they're in college.
You are all taking
I
AP
think
tests.
We get to take it for free, but we have to pay to not take it?
Well, this is already bought the test, so yeah.
When I tried to drop it, well, I didn't try to drop it, but I asked if it's possible, if I could drop the class. She told me they already bought the tests, and if I wanted to drop the class, I would have to pay the $30. So I'm assuming if I don't take the AP test, I have to pay for it anyways. So basically, Jeff had to pay $30 to drop.
Oh, yeah, did he?
Yeah. Well, I don't know.
They probably didn't buy them a test to start with.
Failing out of the class, but it's.
Well, you still
Would you
enrolled
have
in
to
the
like
class.
come in and take it?
Yes. It is a paper test, which I'm so thankful for.
Did Jeff get kicked out, or was he?
No, he dropped it.
Oh, I thought he failed.
Well,
Even if you did, you can still
You
take
did
second
fail.
semester.
Yeah. So this one asks us to find the volume of the solid formed by revolving the region, bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. So the first thing I'm going to do is I'm going to draw a picture.
At least this hard.
On the homework?
Yeah.
Come on, give me some credit.
Facts.
No, that's all I heard there.
You always get the hardest problem.
I don't try to, but
Yeah, but the notes, like,
Don't.
I understand the notes and then when I get to homework,
I feel like she's at home kicking herself in her room. She's like,
Kicking herself.
dying laughing with her kid. She's like, I think this is a hard problem. Tell her kid.
I mean, I do talk to her about the math that I do, but
No,
I do. She thinks it's fun. She smiles.
That's because you're just talking to her.
I know, but she doesn't know any better. She's absorbing all of this.
She's
It will
like,
be in her brain somewhere.
I could just tell you like I books about her.
She likes them, okay?
She's like, just
She
tell me
can't
because
say-
she doesn't understand the
yeah.
words.
Probably.
She's like,
Yeah, she can't say if she likes him or
But
not.
her first word is parabola. I don't think it'll be very funny.
That would be,
I would die. That would be great.
That
Oh.
would be
that
hilarious.
is better than mom.
Kids start with the.
She started with dad anyway.
Oh.
Oh, she said
That's
that.
kind of like,
Just a dad, but yeah.
That was her first word. She already spoke.
She spoke, yes.
you can pretend like she was saying it out of anger.
That one right there. Okay. So this is the picture that I have. Right? This is the graph that I have. I am trying to find the volume of this whole thing rotated about the y-axis. Right? We're okay there. We're rotating about the y-axis,
Yeah.
which means it's a vertical rotation, which means I need to change it in terms of y,
Well, half of it's hard.
because it is a vertical rotation. The only thing I have to change is that one. That's the only thing I have to change in terms of y.
So it goes from 0 to 1.
So it's going to be y equals x squared plus 1 to begin with. We subtract the 1, and then we square root it. So the function for my curve is the square root of y minus 1. Are we all okay with that?
Yes.
What do we notice about this curve or this shape on the area I'm trying to find the volume of?
It's only one more.
It's gonna be like a couple.
It's actually two different shapes in one.
Oh my gosh.
So below where it crosses the x-axis, where it crosses the y-axis, this is solid. There is no internal radius for me to take out. So this is actually a disk. So I'm actually finding the volume of two different shapes and then adding my volumes together.
Why? I see one shape.
So this is going to be a disk volume. This is going to be the washer volume.
I don't know whether it's just.
You could, but I'm going to show you, like, this is just easier. It comes out working out this way.
Also, just find the volume of that cylinder.
And I'm not saying you can't, because this is better. Okay,
Which is easiest wash.
so we're gonna split this into two. My first is going to be the disk, and then it's going to be the washer. What is the domain on which the disk applies on my y interval, or my y-axis?
0 to 1.
0 to 1. So right here is where that disk exists, because my function hasn't been introduced yet. So this applies on 0 to 1, which means my integral is going to go from 0 to 1 for this section of my volume. What then is the radius of this cross section?
Y minus 1 squared.
Just 1. This is my radius, and this goes from 0 to 1. So my radius for this disk equals 1. So I can calculate the volume here.
Oh, yeah.
This volume is equal to the integral from 0 to 1 of pi times my radius 1 squared, and then dy. That's super easy, right? I know you don't like it.
I liked it before.
Which means that from 1 to 2, because my curve intersects x equals 1 at 2, it's going to be a washer. So it's going to be just like what we've done already. So my washer goes from 1 to 2, and I'm going to have two different radius that I'm looking at. Right?
Yeah.
Since I'm rotating around the y-axis, my first radius goes to the part that is farthest away, which is the line y equals, or x equals 1. My smaller radius goes from the y-axis to the curve, which is my little r, and is the function square root of y minus 1. And then it works the exact same way.
Wait, so what was big R?
Big R went from 0 to 1, so it's 1. Little r goes from 0 to the curve, so it is the square root of y minus 1. So integral from 1 to 2 of pi times, and then we plug it in like normal. Big R equals 1, little r equals my function in terms of y. And I can still just put it into my calculator.
How does that do that?
The only difference on this one is that we did a disk and we did a washer. Plug it right in. You'll have two different integrals that you're plugging in. So make sure you're paying attention to that part of it.
I can put the pi in front of the first one, right?
Yes, you can put the pi in front on both of them if you choose to.
It's easier.
That's fine. I got 3/2 pi, but that is the same as 4.7124.
Yeah, something like
Did you go from 0 to 1 and 1 to 2 for your integrals?
where we're supposed to add them together.
Yes, because you have to take your two different volumes and put them together.
Do that. Yeah, and it's 3 pi over 2.
Yes, 3 pi over 2.
Whoa, I got like 0.195.
For each, for the sum of them, or?
Oh wait, no, I subtract.
Okay. 4.7124 is what I got.
How do I get the answer to show up?
Try
Like, you know how you answer, then you type the next one?
Oh,
Yeah,
you
I
do
got
seconds and then it's with the negative.
Yeah, I got 6.0881.
Check it again. Did you get it, Erin? Yes, correct.
You get the washer one backwards. I feel like,
No, we did the one farthest away
oh my god, we're.
minus the one closest. Because we're rotating around the y-axis, not x equals 1. It's the square root of x minus 1, which should all be under the square root.
Is y minus 1 all under?
Yes, y minus 1 is all under the radical.
That's it.
That's it, we are done now.
Just cheers.
How do we feel about this?
Not
Was it
super-
terrible? Was it the worst?
Alright.
Okay, your homework
Last one's a little-
is one question
Is it like the
and
last
it is
one?
due tomorrow. I feel like it's close.